Hello friends, today we will solve a gate question which came in year 2013 and 2013 was conducted by IIT Bombay. So this is a very good question to understand the concept of Zener diode or voltage regulator. So the question is given in the diagram. So the question states the knee current is 10 milliampere. To maintain 5 volt across RL, the minimum value of RL in ohm and the power rating of the Zener diode in milliwatt respectively are. So we have to find the minimum value of RL and the power rating of the Zener diode to maintain 5 volt across RL. So let's see how to solve. So for this type of question, always use 3 steps. Step 1, find IS. IS is this current coming from source. So IS is, see, this is a Zener diode and this question is based on voltage regulator. So let's assume that Zener is working in reverse breakdown region. So the voltage across this Zener diode is 5 volt. So Zener diode is behaving like a voltage source whose value is 5 volt. So this is 5 volt. So this potential will be 5 volt. So IS will be 10 minus 5 divided by 100, which is 5 by 100, which is 50 milliampere. So this is step number 1. Step 2, find IZ. See, IZ is current flowing through the Zener diode and this is load current. Okay, so I can apply a nodal equation at this point. So these two currents are going out, so IZ plus IL is equal to IS, correct? This is the relation. From here I got IZ equal to IS minus IL. Now step 3, use knee current. For this diode to behave as a reverse breakdown region, the minimum current which should flow through this diode should be 10 milliampere. The knee current of a diode is 10 milliampere. So the knee current is basically the minimum current which should flow through diode such that diode is in reverse breakdown region. So IZ should be at least greater than IZ minimum, which is also equal to IZ minimum is also knee current. So the current, whatever current is flowing through the Zener, it should be at least greater than IZ minimum, such so that your Zener diode is working in reverse breakdown. So I will substitute this value IS minus IL, it should be greater than IZ min, and IS is 50 milliampere minus IL, it should be greater than IZ minimum is 10 milliampere. So IL, it should be less than 40 milliampere. This is one condition we got. Now from this side I can write IL is current flowing through load RL, right? So IL, the voltage across this RL is same as 5 volt, right? So IL I can write it as 5 volt by RL, voltage by resistance is current. So we got a condition IL should be less than 40 milliampere, and IL I can write it as 5 volt by RL. It should be less than 40 milliampere. From here I came to know RL it should be greater than 5 by 40 milliampere. It should be greater than 5 by 40 milliampere. So RL min it should be 5 by 40 milliampere. So this is equal to 125 ohm. Now for power rating, I have the formula of power rating is Iz max into Vz. So we have to calculate Iz max now. So we have seen a relation Iz is equal to Is minus IL. So see, Is is fixed. Is is fixed and its value is 50 milliampere minus IL. So for Iz max, here IL should be 0. IL should be minimum, right? If IL is something like 10 milliampere, so Iz max will be 40 milliampere. But if I put IL to be 0, then Iz max is 50 milliampere. So no current should flow through RL, then only the total current will flow through Zener diode, and that will be the maximum current. So IL should be 0. So Iz max will be 50 milliampere, and power rating will be 50 milliampere into Vz was 5 volt, and this will become 250 milliwatt. This is the answer.